Okay, I want to give you some examples of hypothesis tests and a little bit about the logic behind them. Hopefully you've had a chance to read section 9.1 and 9.2 in the book and already have an idea of what the null and alternative hypotheses are and the notation. H sub 0 is the null hypothesis and H sub A is the alternative hypothesis. And the null hypothesis is what you're going to assume to be true, and the alternative hypothesis is the opposite. Sometimes the alternative hypothesis is called the research hypothesis. It's essentially the hypothesis that indicates why you are running the test. I don't think our author calls it the research hypothesis, but statisticians a lot of times do. The null hypothesis is what you'll assume. It's what you'll assume to be true. Now let me give you an example of a hypothesis test. Suppose I'm a consumer advocate, and my job is to make sure that the consumer gets what companies are claiming to give. And let's say I'm going to go ahead and test a canning company, a pop canning company. Actually, there is a pop canning company over on Kiowee Street, and they distribute cans of pop to several supermarkets in the area. And right on the can it says 12 ounces. And I want to test that. I'm going to go out and get a sample of cans, probably find all the stores that they distribute to and collect a random sample of a few from each store, bring them back to the laboratory, measure the amount in the cans, and I'll have some evidence. To set up the test for that, what am I going to assume is true? That's the first step of a hypothesis test. What are you going to assume, and what's the alternative? Well, I'm going to assume that the company is true to their claim. The book likens hypothesis testing to a courtroom and a prosecutor bringing in a person before a jury with evidence. Up until proving that that person is guilty, the assumption is that the person is innocent. So I'm going to assume the company's innocent. Once more, I don't care if the company is actually overfilling the cans. That's okay because the consumer benefits from that. I'm really checking to see if they're underfilling the cans. My research is to check and see if they are underfilling the cans. I'll assume that they're putting at least 12 ounces in the cans. And the opposite of that is that they're not. Now, the book talks about how to run a hypothesis test and the conclusion of hypothesis test based on sample evidence or sample data. You either will reject the null hypothesis. In this case, if I reject the null hypothesis, I'll have proof that they're underfilling the cans. I'll have proof that the alternative is true. The other possibility for the conclusion of a hypothesis test is do not reject. In that case, the test is inconclusive. It's interesting that do not reject does not mean necessarily accept. And in a courtroom, when they bring a person in for trial and the prosecutor has evidence that he believes will convince a jury that this person is guilty, suppose that evidence is not strong enough to do that. That person is assumed innocent. The judge then, or the conclusion of the court, is not guilty. It doesn't mean that the person is proven innocent. It just means that the prosecutor didn't have enough evidence to overturn that assumption of innocence and prove the guilt. That's why they don't say innocent at the end. They say not guilty. Same thing here. We'll either reject the null and have proof that the alternative is true, or do not reject the null, inconclusive. We'll go ahead and assume the null is still true. We're not trying to prove the null. We've already assumed it's true. Why this person is going out and getting those cans of pop and getting that evidence and running the test is he believes he may have some evidence to show otherwise. Whether the evidence is strong enough to do that, we'll have to wait and see. But the conclusion of a hypothesis test is reject. The alternative is proved. Do not reject, inconclusive. And then maybe another day we'll get another sample and check it again. Now let me give you another example. of a hypothesis test. A little different situation here. Same company, let's say, but the person is not a consumer advocate. This person works for the company, and he's looking at these canning machines, and his job is to shut them down and fix them if they break. Well, the way he's going to determine whether they're working well or not is to go out on the line every once in a while and get 30 plus cans of pop and pretty much do the same thing, measure the amount in the cans, make sure that the cans are being filled properly. Now, a little bit different situation with this person. He not only cares of whether the cans are being underfilled, he would also care if the cans are being overfilled, because overfilling the cans, the company's giving the consumer more than they promised, and that could be considered a waste of product. In other words, it's costing the company more. They don't have to do that, and they may want to save that money. When he comes in the morning, this person that's in charge of monitoring the machines and making sure they're working well, what will he assume? Well, he'll assume that the machines are working well. He has no evidence to show otherwise until he collects his sample and takes a reading, so he'll assume they're working well. His research hypothesis is, or the alternative, is that they're not working well, that they need to be shut down or adjusted or something fixed. Now, again, what will he assume? He'll assume the machines are working well. He'll assume that the status quo is machines are working well. There is no evidence to show otherwise. We're not going to start by assuming they're broken and shutting them down. No, we'll assume that they're working. We'll wait and see if the evidence is strong enough to show there's a problem before we shut them down. So when he runs the test, he'll either reject the null and shut the machines down, he'll take action, he'll have proof that the alternative is true, or he won't reject the null, do not reject, and therefore the test will be inconclusive. He'll let the machines run, they're assumed to be working well, he'll take a sample maybe in an hour or two and see if the evidence there is strong enough that show that the machines are having a problem. But again, he's either going to reject the null and shut the machine down, take action, have proof that the alternative is true, or the conclusion would be do not reject the null, inconclusive, leave everything alone, and take a sample maybe later. Another example of a hypothesis test, this one a little different. Let's say that I work for a car dealership, and I'm the guy that's supposed to come up with bright ideas to increase sales. And the salesmen at present, say, are selling on average 10 cars a month. Each salesman sells on average 10 cars a month at this dealership. And my job is to come up with, say, some kind of incentive plan. And I think I've got one. I've got one that I think will increase sales, that will increase the average from 10 cars a month to something higher. Well, this incentive plan is going to cost the company money, and the company's probably going to want some proof that it's working before they invest in it. So I'll have to start the incentive plan and test it to see if it does work, to see if it does help the salesman or encourage the salesman to sell more cars. What will I assume in testing my incentive plan? Well, right now, the average cars being sold are 10. I put the incentive plan in place. Does it help? What will I assume? Well, I'll assume that the incentive plan does not work. It seems kind of odd to make that the assumption. But to prove anything, whatever you want to prove has to be the alternative. Right? I'd like to prove that my incentive plan is doing a better job, that the salesmen are selling more than 10 cars on average. Well, the only way to prove anything is to reject its opposite in this kind of hypothesis test. So I'm going to assume that my incentive plan is not working, and hopefully when I collect sample data at the end of a month or two, I'll be able to have strong enough evidence to reject the null and prove that my incentive plan works, that it is increasing the average amount of cars sold in a month. Now again, that seems kind of odd at first, but for this particular type of hypothesis test, the only way I can prove anything is to reject the null hypothesis. If I would have assumed that my incentive plan is working, then the only time I could prove anything is to reject that. Then I'd never have proof that my incentive plan was working. So it really makes sense in this kind of setup to make whatever you're trying to prove the alternative. Okay, now in running a hypothesis test, there's two types of error. The first error is called type 1. And type 1 error is rejecting the null hypothesis, or H sub 0, and in reality, H sub 0 is true. Rejecting H sub 0 and H sub 0 is true. That would be a mistake. In the first case up here, rejecting the null hypothesis, remember the consumer advocate is trying to prove or gather evidence to see if the company is underfilling the cans. If he rejects the null hypothesis, then what he's saying is that they are underfilling the cans, that the assumption of the cans having at least 12 ounces has been rejected. But suppose in reality that's not true. The company is giving 12 ounces in those cans on average. Then the tester has made a type 1 error. And type 1 error, we would want to avoid that. There would be consequences in a situation like this. You're claiming that company is lying to the consumer when they're not. A type 2 error in the second case would be that you would shut the machines down. You rejected the fact that the machines are assumed to be working properly, and you're shutting them down for repair. But in reality, the machines were working properly, and you've made a mistake in shutting them down. Well, that could be costly to the company. It would be loss of time and product. So you want to avoid a type 1 error. You want to avoid rejecting the null when the null is true. Third case. This is the one where I'm trying to test an incentive plan. This incentive plan is costing the company money. And if I reject the null, I'm basically saying that the incentive plan is working. But suppose in reality that's not true. The incentive plan is not working. Well, that would be a loss. The company would be spending money on an incentive plan that's not really helping the sale of cars. And again, type 1 error there would be costly, and you need to avoid it. Another type of error would be type 2. Type 2 error is accepting the null hypothesis, and the null hypothesis is actually, in reality, false. Again, that's another type of testing error that could happen. In the first case, accepting the null hypothesis is saying that that the company is actually giving the consumer exactly what they say: 12 ounces of 12 ounces of pop in cans or better. And in reality, they're not. In reality, they are underfilling the cans. Well, then the consumer is paying for a product that they think they're getting and they're not. So type 2 error would be something to avoid also. Type 2 error in the second case is accepting the null hypothesis. Again, would say that the machines are working. And in reality, they're not working. They need to be shut down and fixed. Type 2 error would need to be avoided in this situation because those machines might be filling these cans wrongly or underfilling them for several hours, and some of that product would have to be dumped. If they're overfilling the cans for several hours, then the company is spending more money on content there than it doesn't need to. And either way, the company's losing money. So type 2 error would need to be avoided. Type 2 error in the third case would say that, again, the null is true and the incentive plan is not working. when in reality the incentive plan would work. But because you've accepted the null, you're not going to use the incentive plan. So again, that's kind of a loss. Type 1 and Type 2 errors need to be avoided. Now the interesting thing here, for the type of hypothesis testing in our book, and really the type of hypothesis testing that's most generally used, we avoid Type 2 error just by never accepting the null hypothesis. Remember what I said, the conclusion of a hypothesis test is either reject the null or do not reject the null. Do not reject does not mean accept. It just means that the evidence provided was not strong enough to reject the null. Do not reject is inconclusive. And again, in a courtroom, that's the same sort of thing, that they either find the defendant guilty or they say not guilty. It's never a burden upon the defendant to prove their innocence. The burden is upon the prosecutor to prove the defendant's guilt. So the courtroom at the end doesn't say innocent, proven innocent. No, they just say guilty or not guilty. The evidence wasn't strong enough to prove the guilt. We'll continue to assume the person's innocent. They're free to go. We avoid Type 2 error in hypothesis testing in much the same way.
We just never accept the null as proven. We say either reject the null hypothesis, and we've proven the alternative is true, or do not reject the null hypothesis. Inconclusive. We've proven nothing. We'll go ahead and assume the null hypothesis is the way it was, the way we assumed it to be, but we won't say that the null hypothesis has been proven true.